Okay. Lecture part 5, lecture 7. See? Part 5 is properties of the matrix. Okay? This is a second order tensor. Gij is a covariant component. Okay? And Gij, this is contravariant component. This upper indices, this is lower indices. Second order. Okay? Now, I want to prove, okay, property of the partial derivative involving the terminal of Gij. Okay? Don't forget that the terminal of Gij, this is what we call G. Okay? Now, this is an important property that we use later. Partial derivative of Xi, you see, attention now, this Xi over here belongs to the space vector, but I here, upper index in the denominator, is covariant. Attention now, okay? This is contravariant here, okay? But in the denominator, this I here is a covariant index. Now I'll prove that this is identical to 0. I'll put identical. Okay. Where Xi is the contravariant of the curvilinear coordinates belonging to the space vector. Okay? And AI here, you see here, AI belongs to V star. I would like to point it out that, again, this R is invariant. You can look at here, okay? Depends on the Cartesian coordinates, and this depends, in this case, of this contravariant coordinates that belongs to V, you see, the blue one, and this is the red one, that belongs to the dual space. Cartesian coordinates, we don't distinguish covariant and contravariant, okay? Is identical, okay? There's no distinction over here, okay? Now, you see the blue one, they belong to the space vector, okay? And the red one, you see this lower index here, it belongs to the dual space vector. Okay, now I want to expand this. Okay, this I here is dummy, okay? Remember that AI, by definition, is given by this relationship. This JK, okay, covariant. Now attention now, okay? Always remember that IJK, they are cyclic, you see? Cyclic. And also, this denominator, you just write here, you see, remember that AI dot AJ cross AK square is equal G. Just go back to part 1, you see this derivation in detail, step by step. Now then, see, I take this square here, okay? And this is square root of G. So this one is square root of G. So I can multiply, you see, is square root of G times AI. Okay? Look, square root of G times AI. This is just the numerator here. If you multiply here, you see, then it'll be AJ, AK. So I'll expand this cross product, okay? Before expanding, I will show you a very, very important property, okay? Then of the basis vector. You see, I can swap here, okay? Because AI, you see, AI here, AI, this is partial respect to Xj, Ci. So this is a second derivative, you see, second derivative. second derivative. I can swap I and j in this second derivative. You see, I swap I and j, okay? Clearly, okay? This is j, this is I. Look at here, this is I, this is j. Then I can write, okay, the same expression, okay, swapping. Then I have partial of ci, partial r respect to j. You see, look at here, you see follow here. And look at here, I just swap j and I. And I will use this down here, okay? Now, I call the green one, the green 2, the green term 3. I just show, I copy from there to here. Attention now, this is a cross derivative of a cross product. You have to pay attention in the order, okay? First I derive A2, cross A3. Then I repeat A2, in this case, okay, I repeat A2 and derive A3. Okay, that's a term 1. Likewise, the same as in term 2. Okay, the term 2. I derive first A3 cross A1 plus A3 cross derivative of A1. It's written here, okay, quite clear. The same as the term 3. Okay, I copy from here to here. Okay, I just develop, okay, in two terms over here. This is term 3. Now I'll use, attention now, I'll use this relation here, okay, just to cancel. Okay, it's quite easy, there is no problem. You see, I can swap here. There is no problem, I can swap, okay? This cross A3 remain the same, and I swap here, 2 and 1, here's 1 and 2. I just using this relation. It's quite clear, okay? The same I will do with the green one, the green term 2 here, okay? I'll swap, there is no problem, okay? And then with the term 3 green, okay? This term is quite easy. You can follow here. See, for instance, term 3 here, this is minus because cross product is skew symmetric. So I can, in this case, okay, I can do this product, the cross product here, I can exchange here. You see, this will be A2 minus A2. You see, just minus here. You see, quite easy. Okay. The same over here. Okay, I can swap here. You see clearly, there is no problem. I exchange the sign, okay, and swap this, leave this term here. Now, if you follow, you have a pen, okay, just writing on your paper. You see clearly, this is, I use this relation here, okay, that's a very important, this relation, just to cancel. Now you see colors, okay? Now, you see this red straight line, will be canceled. See, when I expand this, okay, I have the red. See here, this one, okay, will be canceled, okay, the same. Look at here, and look at here. Look here and here. Now, this is 2 straight lines. See, this is 2 here, this is 2 over there. Just look at here and look at here. Also, you cancel, and this 3. Straight line will cancel with the 3 straight line. Okay, that's easy. You see, this 3 here cancel with this. Okay, you just follow. So the sum, okay, will be 0. Okay, because each term cancels with the other one. Okay. Now this plus this will be 0. So this is proof. Okay, that this here is 0. Okay? That's it.